This is Unit 9, Lesson 9, and we're going to be looking at nonlinear systems and how to solve them. We'll be solving them in two different ways. Today in Lesson 9, we're going to be solving them by graphing, and in the next lesson, Lesson 10, we'll be solving them using algebraic methods like elimination and substitution. So just a quick definition, a nonlinear system of equations is a system of equations in which one or more equations are not linear. So that means they could be parabolas, circles, ellipses, hyperbolas. Okay, so it might be one line in one nonlinear equation, or it might be two nonlinear equations. We'll see a little bit of everything. So solutions to a nonlinear system, same as the solution to any system, but the solution set to a system of equations is, is the set of points in which the equations intersect each other. So just to give you that visual, when you're graphing them, if the two intersect each other, that means it's their solutions, because that's the point or points that the graph has in common. All right, so there might be one solution, multiple solutions, or no solutions. So if they intersect exactly once, they might intersect in 2, 3, or 4 different points, depending on the shape of the graph, or they might never ever cross each other, and that means there are no real solutions. So that is what we are going to be looking at in today's lesson. So we're going to do a handful of these on each page, starting with number 1. So we're going to have a refresher on how to graph each one. None of this is going to be brand new. We're just taking all of the graphing methods that we've done before, kind of putting them into one lesson, and then looking for the intersection points. So this right here, we've got y equals negative x squared plus 7. When we graphed parabolas, we made a table. All right, so this, we found the vertex, we made a table. So this one right here, the vertex is x equals, remember the formula, negative b over 2a. So with this one, b is the x term, and there is no x term, so we know that's just gonna be 0. So when we create our table, remember the vertex goes in the middle, and then we go back a couple points, we go up a couple points. We'll see if that's enough, and I'll talk to you as we go through this, how you can figure out how many points is enough. All right, so let's start this way. Negative 0 plus 7 would be 7. Negative 1 plus 7 would be 6, which means this would also be 6. 2, so negative 4 plus 7 would be 3, so this would also be 3. So let's start with those points and then graph the line and see if that's enough. So negative 2, 3, negative 1, 6, 0, 7, and then we have symmetry back down the other side. So I'm not going to connect the dots yet, and I will explain why. Now we're going to plot this, y equals x plus 5. So this is just a line. We start with our y-intercept at 5. So 2, 4, 5 right here. And then our slope is 1. So we go up 1 to the right 1. There's one intersection right there. Up 1 to the right 1, up 1 to the right 1. We want to do this enough to make sure that we're actually intersecting that parabola. Okay, so we can also go, so here's the parabola right here, just to make sure we're not getting confused with all the points. So there's our parabola. We see we already have one intersection point right there, and then we can also go down one's the left one, down one's the left one, there's another point, down one's the left one. So there's no like tried and true rule as to how many points you should plot, but you need to plot enough points to know where they're going to intersect each other. That's the rule that I want you to stick with. So we have one intersection point right here, one intersection point right here. For our solutions, we're writing down the ordered pairs. So we've got this point right here. That is 1, and then 2, 4, 6. 1, 6. So our solutions today should all be in ordered pairs. 1, 6, and then this one right here is negative 2, 3. Okay, so that's how that works. Graphing is nothing new. All we're doing here is we are looking for the intersection points. So let's now look at number 4. All right, so this one, y equals, we've got a parabola right here. We're going to start with the vertex, x equals negative b over 2a. So negative b would be a negative 2 over 2a would be 2 times 1. So this comes out to be a negative 1. So negative 1 is going to be in the center of our table. And then we'll go back 2, we'll go up 2, see if that's enough. We might need to add more, and I'll show you why in just a second. So if we start with the vertex, sub in a negative 1, this will be 1 minus 2 minus 8, so that's a negative 9. If I sub in a 0, I get 0 plus 0 minus 8, so this is a negative 8, which means this is a negative 8. 1, I get 1 plus 2 minus 8, which would be a negative 5, so this is a negative 5. So let's start with those points, just see if that's enough. So we have negative 3, negative 5. We have negative 2, negative 8, so 2, 4, 6, 8. Negative 1, negative 9, and then we mirror back up the other side. All right, so that's where our parabola is. Here's our line. We need to rearrange it just a little bit. So get the y by itself. I'm going to add the y over to the right-hand side. So add the y and then subtract the 5. So 4x minus 5 is equal to y. So that's my line in my slope-intercept form now. So same as I graphed this one with number 1. We start with a y-intercept of negative 5. So that's part of my line. And then my slope is 4. So I can go up 4 to the right 1, up 4 to the right 1. I'm going to just fill out the whole thing right here. Up 4 to the right 1, and then I'm on a space. All right, so now let's go down. So down 4 to the right 1. So there's 1 point. So I know it intersects there. And then if we look at the parabola, so I've got 1 right here, but I need to extend my parabola a little bit, which means I need to add more points to my table. All right, so I'm going to add 2 to the table. So 2, if I plug that in, I get 4 plus 4 minus 8, so that would be 0. So 2, 0 would be this point right here. That's not an intersection point. So I need to add another one, 3. If I plug in 3, I get 9 plus 6 minus 8, which would be 7. And that is this point right there. So there's my intersection. So now I can connect the dots. I found my other intersection point. So I've got a point right here and I have a point right here. So if you write those down, this point right here is that. That's the point 3, 7. And then this point right here is the same as the vertex of the parabola. So that's this point. All right, so that's our solution for number 4. Let's take a look at the next page. We're going to look at just 2 of them on that next page, starting with number 7. So number 7, we've got 2 parabolas, which means we're going to have to sneak in 2 graphs here. Start with this top one. Our vertex is x equals negative b, so that's a positive 6, over 2a, which would be 2 times the negative 1. So our vertex here is a negative 3. Let's make a table for that. So go down a few points, go up a few points. We'll see if that's enough. So start with my vertex. This one's a little bit tricky. This is negative, and then I square it and I get 9. So this actually is a negative 9, and then a positive 18, because I'm plugging in something negative. So negative 9, positive 18, minus 11, and I end up with a negative 2. Then this, when I sub in negative 2, I get negative 4, and then this ends up being plus 12. Minus 11. So that's a negative 3, which means this is a negative 3. And then when I sub in the negative 1, this is a negative 1 plus 6 minus 11. So that's a negative 6, and so is this. So let's plug in those points. So negative 5, negative 6. That's our first point. Negative 4, negative 3, negative 3, negative 2, and then I mirror back down in the other direction. All right, second parabola is this one right here. I have y equals x squared minus 4x. So start with my vertex. X equals negative b, so that's a positive 4, over 2 times 1. It ends up being 2. So I am going to put our table right here because I'm not going to do number 8. So put this 2 in the middle, go back a couple points, go up a couple points. I'm actually going to start with this end of the table because those numbers look a little easier to me. So start with a 2. 2 squared minus 4 times 2 would be 4 minus 8. That's a negative 4. Then I can sub in the 1. 1 minus 4 would be a negative 3, and so is this. And then sub in the 0. 0 minus 0 is 0, and so is this. So first point, 0, 0 is at the origin. Then 1, negative 3 is right here. 2, negative 4, and then it mirrors back in the other direction. So this, we mentioned on the front page, you might have 1 solution, 2 solutions, 3, 4 solutions, or no real solution. So these parabolas, no matter how far you graph them, they are never going to intersect each other. So there is no solution for number 7. All right, one final problem we're going to look at here is number 10. Number 10, if you look at these equations, this one is squared, this one is not, so that is a sideways parabola. So we're going to get a quick recap on how we graph those parabolas. And then this is an x squared and a y squared, positive 4, positive 9, same sign but different numbers. That makes that one an ellipse. Okay, so we're going to remind ourselves of how to graph these. They need to both end up in standard form. So this one, standard form for a parabola just means factoring out this front term right here. So factor out the negative 4, and I have x minus 1. So let's graph that first. The vertex is positive 1 and then 0. So that's this point right here, 1, 0. So I'm going to make a few notes on that. Oops, 1, 0, sorry. Ignore that little splotch there. So 1, 0 is our vertex. We can solve for p. Remember, 4p is equal to whatever this number is. That's a negative 4. So p is equal to negative 1. Since this is a sideways parabola, this means that it opens up to the left. So this is my vertex. My focus would be plotted just 1 point to the left, which means my directrix would be right here. And then I can plot a couple more points here. These two things are 2 units away. The focus and directrix are 2 units from each other. So I go 2 units from the focus. This is a point on the parabola. This is a point on the parabola. So now these points are 2 units from the directrix and 2 units from the focus, just like these points are 1 unit. The vertex is 1 unit from the focus, 1 unit from the directrix. So connect the dots here. This is our parabola. We're going to see where it intersects that ellipse. All right, so ellipse, standard form. This 36 is not supposed to be here. So divide everything. This reduces. 4 over 36 is x squared over 9. Plus, this also reduces to y squared over 4, and then of course this is just equals 1. So our center, the center of this ellipse, since this is just x squared, just y squared, this would be 0, 0. So here's our little center, same place as the focus actually. And then in an x direction, so under the x I have a 9. So the x direction is left and right. That means I'm going left and right 3 units. So 3 squared is 9. I go to the left, 1, 2, 3. I go to the right, 1, 2, 3. And then my y direction up and down, I have a 4. 4, the square root of that is 2. So from this center, I go 2 units up, 2 units down. I actually land right on that parabola. So these 2 points right here are my intersection points. So 0, 2, and 0, negative 2.